Welcome to Video 3, Using Tools to Solve Problems. In the last video, you learned how the counting all strategy helps children use direct modeling to understand the steps of addition and subtraction problems, and the thinking that accompanies those steps. In this video, you will study how using tools to directly model amounts can help children move beyond counting all and become more efficient and flexible math thinkers. Using tools can help children learn how to operate on representations of the quantities of objects to be counted, even when the objects themselves are not available for counting. This is, after all, what addition and subtraction are: ways to determine how many when sets are combined or when objects are removed from a set, even without actually combining or separating the objects themselves. Using tools to directly model these combinations and separations helps children build their understanding of addition and subtraction. The key here is representation. That is, each tool we will discuss provides another way to represent quantity. There are many times and situations when counting the actual objects is not possible. Perhaps because the objects are not here with us right now. Perhaps because we are counting sounds or ideas, where there is nothing we can point to while saying the number words. Tools that represent and allow us to work with quantities in the abstract are perfect here. This is why the third key instructional practice for solving basic problems is: use a variety of tools, including objects, fingers, drawing, and 5 and 10 frames to solve problems. Tools that can represent quantities are especially useful when things are changing and we need to keep track of something mentally. They help to model the transformation itself, so we can focus on the amounts. With each of the tools we will discuss today, children use them to create models that can represent the quantities of the sets and the changes to those sets they are trying to understand. When you first begin to use tools to solve problems with young children, it's best to start with the counting all strategy that was discussed in Video 2 and focus on addition. Perhaps the first and most important tool for representing quantities is children's fingers. If a child is told to gather 6 crayons and they know how to count their fingers, they can put 1 crayon next to each finger on one hand, and then add 1 more crayon to get 6, for example. Fingers can also be used to model 2 sets being combined if the amounts are small enough that one hand can represent one set and the other hand can represent the other. With 3 fingers held up on the left hand and 4 fingers held up on the right, a child who can count to 10 can count all their fingers to find the resulting amount of 7. Drawing is another tool children can use to directly model quantity. For preschoolers, it is helpful to start using drawing to simply make a visual record of how many. First, children place their set of small objects on a paper. Then they draw 1 circle around each one. When the objects are removed, the circles left behind can be counted to tell us how many there were. Experiencing this is useful for clarifying children's understanding of how representations of amounts work. The realization that 4 is the same for the objects and the circles is a profound one. There are also more complicated ways to create and use visual records of quantity, such as making tally marks to keep track of how often something happens. For example, you can use tallies to mark how many times someone is able to jump in 10 seconds, or how many days this month it was sunny. These examples are more like counting than they are like problem solving. But with kindergartners, tallies can also be used to model changes in quantity very effectively. For example, the simple word problem: I have 7 markers. How many will I have after I give Joseph 2 of them? Is an ideal problem for using tally marks and a counting all strategy. 5 and 10 frames can be similarly used to help children map a quantity change. If there are 4 baby carriages for playground use, Marcus can put 4 chips on a 5-frame to represent this initial set. If one baby carriage is already being used by Samuel, Marcus can remove one chip to represent the one Samuel is using. Once he removes the chip, he can count, or subitize, the remaining chips to learn that there are 3 baby carriages still available outside. By creating this direct model, a representation of the quantity of the carriages that can be easily manipulated and counted, Marcus can solve this math problem without even seeing the baby carriages. Of course, Marcus could use the chips even without the 5-frame to answer this question. But if he is accustomed to using a 5-frame, it provides extra reassurance that his quantities are right. He might feel more confident that he began with a set of 4, and the frame may activate other familiar number relationships in his thinking. These tools, fingers, drawing, and 5-frames, can be successfully used with preschoolers and pre-kindergartners, but only with very small sets. Keeping your total amount under 5 and using 1 and 2 as the amounts involved in any transformations will mean that your students are operating in the realm of subitizing, and that helps them not lose track of what is happening. 10 frames can be used to help kindergartners work with larger amounts. Eventually, children will learn to use a tool to represent just one part of a problem, such as the number to be added, and then use what we call counting on to find their answer. That is, to model adding 3 to 7, they hold up 3 fingers to represent the amount to be added and count forward from 7, as in 7, 8, 9, 10. There are 10 now. This is no longer a counting all strategy because the children did not bother to count the initial amount. They just knew or understood that there were 7 in the initial set and were able to count up from there. This counting on strategy is a landmark achievement. When children can focus on counting the transformation or change only and not worry about counting the initial set, they free up a lot of working memory for thinking about what's happening. They are still using direct modeling, but they are modeling with greater efficiency, an important sign of development in their thinking. These changes in strategy are likely to occur at different times for different set sizes and different contexts. A child's familiarity with a set can sometimes make it easier to move from counting all to counting on. For example, if Jasmine is very familiar with how 4 toy cars fit into a shoebox, but she has 2 more than 4, she might look at her full box and jump to 4 as a starting point to determine the total amount. But later that same day, she may need to count the 4 clay containers on her table, then count the 2 additional clay containers, and then put them together to determine that this new, larger set will be 6. Expect children to move back and forth between counting all and counting on as these strategies develop. For this reason, the developmental progression does not particularly distinguish between counting on and counting all. Instead, the counting-based problem-solving band is about both kinds of direct modeling and provides information about when children are ready to work with different set sizes. Whether they are counting all or counting on, using fingers, drawing, and 5 and 10 frames will help children focus on what is happening with the quantities as they combine and separate.